Okay, welcome back to my programming and ARM assembly video series that I'm doing. And in this series, we're trying to create a general purpose random number generator. Let's get back into the code. All right, so in the previous video, I went through the random.s file and I showed what we needed to do to, open the file, store the file descriptor, read from the file, and close the file. But we aren't actually generating a number or anything at this point. But I also showed what my plan was well, technically we aren't generating the number. This code's not generating a number. This code is just pulling a number from /dev/urandom, but our job is to take that number and make sure that we constrain it within the limitations that are set forth by the driver code that's calling this function. And that was what I was explaining in the last video, how I plan on doing that constraining. So let's go ahead and set that up now. So when we come in to the rand function, we need to move into register 3 the value contained in register 0. And essentially what we're doing here is we're making a backup copy of min_rand, because as you can see, as we go down through this code here, we're going to overwrite R0, we're going to overwrite R1, we're going to overwrite R2. So we need to make sure that we choose a register that's not going to be overwritten later on. All right, so we're going to say that this is going to be our backup of min_rand. And then we're going to move into register R4, whatever value is contained in R1, and that's going to be our max_rand. And then we want to calculate the range. So let's subtract, and we'll say R5 is going to store a copy, or it's going to store the value of R4 minus R3. And that's going to be our range calculation. And we remember we need to add onto our range the immediate value 1, because again, if we say that our number is going to be between 1 and 100, but we want our number to actually include 1 and 100, then we need to add 1, because otherwise 100 minus 1 is 99. But what we really meant, or what we think we mean, is that we want a number that starts at 1 and goes up to and includes 100. So that's the reason that we're doing the +1 there. But before we do that, we want to do a little bit of sanity checking here. Let's compare the range value that we just got against the immediate value 0. And let's say that we'll branch less than or equal to some part of the code that I'm just going to call error. And our promise when we encounter an error, what we set up here is that R0 will contain the error code if there was one, and R1 will contain the value 0 in the event of an error. So let's say move if less than or equal to into the register 0, the immediate value -1. And I'm just defining that in this context, -1 is going to mean that we got a range error. So then we're going to branch down to this part of the code called error that we haven't built yet. So let's call that here. Let's make that here rather. And the other thing that we said was that register 1 will contain the immediate value 0 if in the event of any kind of error, register 1 will just return 0. So we'll make sure that this error section does that. All right, now let's think about this. So we have compared our range against the immediate number 0, and that confirms or verifies that our range is valid and that we don't have a max_rand that's less than min_rand, or our max_rand that's equal to min_rand. All right, so now let's go down to the section where we're actually going to do this division process. Now, so far we don't actually have the random number that we pulled from dev/urandom stored anywhere. We only have the memory address to the buffer right here. So R1 is currently pointing to the memory address where that random number is located, but we don't have the random number itself. So let's load into register 1 the value contained at that buffer space, the value contained at that memory location. Because let's say the memory location is 123, but the random number that's at memory location 123 is 65 or 478,222 or whatever that number is. So we need to actually pull that number out of that memory location and store it. So that's what we're doing there. Now I just basically want to follow these steps that I outlined in the previous video. So we want to divide, and we want to say that R6 is going to be available to the random number divided by R5, which is our range. And you can see that's what I'm doing here. Quotient is equal to rand divided by range. And that's the same thing that we talked about right here in this step. In order to calculate the quotient, in the case of like this number, and if this was our range, then we just need to take 88,073 divided by 251 in order to calculate the quotient. So that's exactly what we're doing right here in this step. And then in the next step, we need to multiply, and we need to say that R7 is equal to R6 times R5. And again, that's exactly what we're doing right here. And that was exactly what I showed that we needed to do up here in order to calculate that the product. Now we need to subtract, and we're going to say that R1 is equal to R1 minus R7. And then we're going to, we potentially have an offset because we don't know that our number is always going to be between like 0 and 10 or 0 and 100. It's more likely that our number is going to be between like 1 and 100, or perhaps 25 and 50, or maybe between 250 and 300. So we want to add in any potential offset. So let's add, and we'll say that R1 is equal to R1 plus min rand, which is R3. Okay, so in all normal situations, we will have successfully constrained our number at this point. So we want to make sure that we don't pass back an error to the calling function. So we'll move into register 0, the immediate value 0. And the reason that we're doing that is because we stated up here that R0 will contain the value 0 if there was no error. So that's just a way that we can make sure, like if the calling function just wants to do a quick check, was there any error of any kind, it can compare register 0 to the immediate value 0. So before we return, we want to make sure that we update register 0 with the immediate value 0. And then I think we're done. So now we can just branch unconditionally to the exit label. All right, so if there aren't any problems here, can't promise that there aren't, but if there aren't, then we should be reasonably good to test this out. So let's write our code and quit. And let me go into the main.s file. And we need to update our driver code so that we can actually see these random numbers that we're generating. Let me take a sip of water. Because currently when when rand returns, it returns an integer value, and we can't actually look at that integer directly. But in the previous video series one of the previous video series I did, I showed how we can convert an integer into an ASCII value so that we can view it. So when rand returns, it has let me actually check. It has R0 contains the error code and R1 contains the random number if there was one. So what we'll want to do, as soon as we get back from rand, we want to compare register 0 with the immediate value 0 because this contains the error code. And then we'll say branch if less than to a section of code called error. And let's go ahead and make that code really quick, or make that label error. And then down here we'll do something if there is an error. Normally there won't be an error, so what we'll do is we'll continue on, and we'll say move into register 1, the immediate value, or rather the value that we got back from, no, I want to do that the other way around. Move into register 0, the random number that we got back from the rand function. Because if we remember, the rand function returns the random number in register 1. Come to think of it, I might actually want to swap these. I might want to make R1 the error and R0 the random number. But for now, we'll go ahead and continue forward. And then in order to see the number, I need to load into register 1 the memory address of some variable somewhere, and we're going to call that variable num. And then once we've done that, we're ready to call our print function. And I have a standalone video where I showed how to create a general purpose print function. The requirement of the general purpose print function is that we pass it a memory address where our string of characters is located, and it's required that that string is located in R1. So let's come up here to our data section, and let's create a variable called num, and it's going to be type ASCIIs, and we're going to just preload that with like 15 zeros. So 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. And if you're wondering why I'm loading it with that many zeros, refer back to my integer to ASCII general purpose conversion function series, and I explain why we need to put all those zeros in there, so I won't rehash that. All right, so we call the random function, we test for error. If there was no error, we should be printing the value, and if everything went well, then we want to unconditionally branch to the exit. And then down here, if there was an error, let's go ahead and handle that. So let's load into register 1. Let's just say error message, and then we'll branch and link to the print function. So let's create error message, and that's going to be type ASCIIs. So let's go ahead and line these up. And we're just going to, for now, we'll just say rand returned an error. We'll keep it fairly simple for now. We'll do some more extensive testing, but for now we'll just keep it as a generic error. Okay, so I think that's everything that we need there. So let's go ahead and quit out of here. Let's quit out of here. Let's make our code. And if everything went well, we should see a random number when we run this, and the random number should be constrained. But no, we got a bunch of zeros. So what did I do? Let me look at the driver code first. So I have loading into, let's see, so we're passing the value 1 into R0. We're doing that. We're passing, or we're calling this function here. Oh, right, I forgot to convert the number. So if there was no error, then we need to branch and link to our I to A function, and that will convert the integer that we got back from the rand into an ASCII, into a set of ASCII. But to do that, I need to make sure that R0 contains the random number and that R1 contains the memory address of. Okay, so I left out a step there. So I think we're good now. And yeah, the more I think about this, the more I think I do want to swap those numbers that we're getting back in rand. That way I don't have to do this step here. But anyway, let me just go ahead and make the code, and let's run that. And now we got 15, and that appears to be a sequence of random numbers between our range. Let me go back into the main really quick though, and let me create a new line. So let's say NL and type ASCIIs, and we're just going to say new line. That way, after we get done printing the number, we can go ahead and load into register R1 the memory address of new line, and then we can branch and link to print. That way we'll get the number followed by a carriage return essentially. Okay, let me go ahead and write that out, and let's quit, clear, make, and try to run this again. And that looks pretty good. All right, so let's so rerunning main every time is going to get a bit tiresome. So let's actually create a loop really quick, just so that we can do like 10 at a time. So when we come into this function, let's move into register 3, the immediate value 0, and then let's drop into a loop. And we'll say that we're going to loop through this, and if everything is good, then when we get to the end here, we're going to branch if less than, and we're going to branch back to loop. But we want to compare the value in register 3 against the immediate value 10. So also we need to add into register 3 the immediate value 1. So that way, you know, we can loop through this like 10 times. And I think that's set up correctly. So let's go ahead and write this out. Let's quit. Let's make our code, clear the screen, and let's run. Ah, that's better. Okay, so now we're getting like 10 numbers at a time. And just based on visual inspection, those do appear to be within that range. Let's go ahead and test some things here. So let's test a coin flip. So like 1, 2, 1, 2. Let's make sure that we're getting both 1 and 2. So let's make our code, let's clear and run. And yep, we're getting 1, 2, 1, 2, 1, 2. We're not getting 0, we're not getting 3, and we're not getting all 1s or all 2s, so I would say that's working. Now let's test an error. So we're saying that calling a random function and saying that we want a number between 1 and 1 it doesn't make logical sense to even try that. So let's clear. So we should just get that message that rand returned an error, and it did. Okay. And let's make another test here, although this is almost the same test, but let's say if min rand is greater than max rand, but let's just make sure that it returns an error. And it does. Okay, so that error handling seems to be working correctly. All right, so I think I will go ahead and swap R0 and R1 in rand. That way, just based on the way that I've already set up I2A and some of the other functions, I think it'll make sense to just go ahead and swap those. Let me think about that. Does it matter? So if we pass back the error into R1, so if we pass the error back into R1, we'll test that here. Does it save us any steps? Because we will still have to load. I guess the only thing it saves us is we wouldn't have to do this. I guess, but that's some savings. And let me just go ahead and try it just to see. So let's go into our random function, and let's say that we're going to swap the way that these work. Let me search for R1, and that's fine. And we don't actually care about R1 until we get like down into here. And this is where we now want to load into R0 instead of R1. So all these now will be R0. And that'll be R0, that'll be R0. And then instead of putting the error in register 0, we'll put the error in register 1. And then in an error type condition, R0 will contain the value 0, and that means that up here, the error will then go into register 1 instead of into register 0. So let's try that, and let's edit our main. So that means normally, now when we come back, we'll check R1 for the error instead of R0, and then that also means that R0 will already contain the random number before we go into the I2A function. And then so the only thing we have to do is load R1 with the memory address of the number. So let's try that. And rand return error because I didn't update these values. So let's say between 10 and 20. And clear and run. And I'm seeing 10, 14. I'm seeing... So in this set, I see we hit 10. In this set, I see we hit 20. So I'm gonna go ahead and do that. I'm gonna go ahead and make that change. So let me just come into randomS, and I'm gonna swap these here. So let me take this and move it down here. And then we're gonna say R0 will contain the value 0 if there was an error. R0 will contain the random number if there was no error. And R1 will contain the error code if there was one, and R1 will contain the value 0 if there was no error. Just by swapping those around, it'll make this function a little bit more cohesive, if that's the right term, with the functions that we've already created. All right, so that's going to be all the time that I have to allocate to this video. We're not completely done here yet because we do need to do some more error checking. So when we come back in part 4, we will do some error checking for opening the file, closing the file, and reading, and then do a bit more testing. And then I think that will wrap up this general purpose function. If you made it all the way to the end of the video, thank you so much for watching, and I hope to see you in the next part.